In this video, we will walk through a co-registration of an EEG data set with the individual anatomical MRI data that was previously recorded and segmented. This data set that I've opened here in BESA Research has a digitized electrode data set, and if we press the V key on the keyboard for viewing the electrode cloud, we can already see that it is digitized on the real head surface, and also a head radius was already computed by the software. So we can use this electrode cloud to perform the co-registration with the individual anatomy. To do this, we'll use the File menu and go to MRI co-registration, which will then trigger an export of the surface head points. I'll save them and also start the BESA MRI software, which we'll then use to perform the co-registration. So after accepting, I get to the first part of the workflow, which is setting the project targets. And here I can decide exactly on the options. So if I didn't have digitized electrodes, I could just simply place them according to their labels if they were if they had been placed according to the 1010 system. And I can also generate additional lead fields matrices for more accurate source modeling. So I'm going to use the finite element EEG. We could also simultaneously generate a boundary element model if we wanted to, and we can see that an extra work step was added here on the left to perform this step. So now I go next. And the next work step is to select my segmented MRI, which I'm going to use this previously performed segmentation here. And it's already loaded. And now my task is to set the fiducial points that I've also used during the digitization again on this 3D reconstructed head surface. The first one is the nasion. So I'll click in here. I can rotate the head, check that I've placed it correctly. Maybe put it a bit lower. This should be fine. And once I'm happy with that, then I can click this button on the right or press the next or simply use the enter key on the keyboard. And the next 2 points are the left and right preauricular points, which usually should be around here. But of course, depending on your digitization protocol, you should just make sure that they're placed in the correct positions that you also used during the digitization of the actual points. Okay, so once I'm happy with that, I go next. And now the next step is to select the co-registration file that is already pre-selected here, and I can simply open it. And we can see that if initial fit is now performed, let me make this a bit bigger. Initial fit is performed trying to fit the fiducials together. We can see that we now not only have the blue, but also these purple spheres, which are the ones that were digitized on the subject. So we can see that these match quite closely already. And we can also put in some additional settings. So in the advanced settings here, we can decide on weights if we have more confidence in certain electrode or other point types, then I can adjust the weights for these. In this case, we only have the fiducials and electrodes, but not the MEG coils and skin points. So I think this is fine as it is. Also, if I, for example, digitize on top of electrodes and had a certain distance from the skin, I could put a distance parameter in here. And there's more advanced settings I can use for the actual search parameters. Most importantly, there's a scaling optimization during the fit, which I can switch on or off. So if it's switched on, that'll mean that the fit also tries to adjust for potential scaling mismatches. Depending on what digitizer was used, this may or may not be relevant. Okay, One more thing to notice is that some of these spheres are little transparent, and that means they will not be used for the fit because they're too low, and low spheres are usually low electrode points would be in the face area, which has a lot of soft tissue, so they're less reliable and will be excluded from the fit. Also, I can remove other points from the fit by right-clicking on them, so then I could disable. So let me just first run this fit. We can see that the initial fit result is quite good. So the mean distance error of 3.7 millimeters, and I can maybe improve it further. For example, if I remove this point, which is also near the soft tissue, I just need to go to the previous step and then right-click and disable it. And I do the same with this one. And then redo the fit, and that will then improve my accuracy further. So if I'm still not 100% happy, then I've got a choice of adjusting the fit results in this area here. So I could use a translation. The Y translation would move the whole cloud backwards or to the front. The X translation left or right, and similarly, we've got the Z translation to move it up or down. We could also scale. So this would then, for example, if I scale in the Y direction, would stretch the electrode cloud further. And we can also rotate in case there's some rotation mismatch. So we can see that we rotate around the X, Y, Z axis in this way. Yeah, but I could also reset the manual correction. And yeah, if I want to see where the electrodes will be used for the actual computation of the lead field, then I can check this finalized co-registration, because that will project the electrodes onto the skin directly. So this is the real position that will be used for calculating the finite element model in the next step, which I'll get to now by pressing the next. And here I can also adjust conductivities. So these are conductivities that will be used for a typical adult brain. But if I want to change it to, for example, adolescent brains or children's brains, then I can do that here. I can change the conductivities in that manner. Good, but I'll stick with the adult brain and run the computation, and this will now take a few minutes to complete. So first of all, the finite element model tool will be initialized, and then calculate the lead fields for each of the electrode positions in turn. Now computation is finished, and we can finish the workflow and save the project in case we want to open it again later. So if I now minimize or close BESA MRI and activate this box here, then I see my green check box. I see the volume and the surfaces that can be used for the head modeling and visualization, and also that there is now an individual FEM available for EEG. Pressing OK will now set these, and I can just run a quick example of source imaging using the individual head model. So if I right-click this block that I just dragged and select one of these features, or go to source analysis and directly identify the interval and the filters I want to work with. Then I can check the head model here, and I can select the individual finite element model. And for example, I could now display the individual MRI that has been co-registered. I could add a couple of sources to model the two bilateral areas for auditory processing, and make use of the symmetry of the bilateral auditory processing and fit these two sources over the main activation. And then I will directly see that they really approach the main facial gyrus areas. And